Hi, and welcome back to Science Wrap. Easter is just around the corner. In fact, you're probably munching on some chocolate Easter eggs right now while you're watching this video. Every Easter though, I'm left with some unanswered questions, particularly around one of the most famous Easter symbols, the egg. So today I thought I'd tackle some of those questions and answer them using science. Question 1. Why are birds' eggs such different sizes and colours? Mostly, the eggs that we see around Easter time are chicken eggs that we then dip and dye different colours. More on that in a second. Now, these eggs have some variation in their size. You can get them medium, large, or extra large. But if you look at eggs in the natural world, they vary hugely in appearance. Take, for example, the bright blue eggs of the robin. No food dye needed there. Or the weird cone-shaped eggs of the common mure. Even the round golf ball-like eggs of an owl. The short answer to my question is that eggs, like other animal features, generally suit or reflect their environment. Bigger birds will tend to lay bigger eggs. Even chickens, the bigger the chicken, usually the bigger the egg. The massive kiwi egg, though, is thought to act like an incubation chamber, so that the kiwi chick comes out more grown up and ready for life on the ground as a flightless bird. Birds that are airborne more of the time, like hummingbirds for example, have more compact, light bodies that squeeze out pointed eggs. Birds that perch more often, like owls, can have wider hips to accommodate a fatter, rounder egg. An egg's colour is determined by only two pigments, which are laid on top of a white calcium carbonate shell. Protoporphyrin makes eggs red, and biliverdin makes eggs blue or green. Often, birds will lay eggs that have a pattern that match the environment. It helps them blend in and stop them becoming a tasty protein snack for a predator. But if your eggs are already hidden, like in a burrow or in the hollow of a tree trunk, then there's no need to spend extra energy and waste time colouring your eggs. You can just make them plain white. Birds might also use colour to help eggs stand out. For example, the bright blue of the robin egg might help signal to a male that the chick from inside the egg is really healthy and that the male should come and feed it. We try and replicate all of this amazing diversity by painting plain old chicken eggs. Which brings me to my next question. Why do you need vinegar to dye eggs? It all comes down to bonding. Yes, painting and dyeing Easter eggs is a lovely bonding experience between you and your family members. But what you're also trying to do is create a hydrogen bond between the dye molecules and the Easter egg shell. Remember how I said before that the egg shell was made of calcium carbonate? Well, that means that overall the shell has a slightly negative charge. By adding vinegar to your dye solution, you're adding in positively charged hydrogen ions. Those hydrogen ions cling to the dye molecules and help attract them to the egg shell, kind of like a magnet. Okay. From chicken eggs to chocolate eggs, and question number 3. How do chocolate eggs keep their nice shape? If you roll in the cooking circles, you might have heard of a process called tempering. That's where you heat up the chocolate to a particular temperature, cool it down again slightly, heat it up again to melt it, and then finally cool it down to let it set. The reason you do this is to give the chocolate a nice snap when you crack it, a beautiful shine, and a great texture. Doing that comes down to forming the right kind of crystals. You see, one of the main components of chocolate is cocoa butter, and that can form different types of crystals, each with a different melting point. The form 5 crystal is the crystal that you want for the perfect chocolate. That's because it can form this nice tessellating crystallized pattern, which gives the tempered chocolate its properties. By heating and cooling chocolate in a specific way, you're encouraging the formation of these particular type of crystals. As a final note, tempering relies on having cocoa butter. So if you're using compound chocolate or white chocolate that has vegetable fat instead, it just won't work and the result just won't be the same. Okay, that's a wrap on Easter science this year. Thank you guys for watching and have a wonderful weekend with your friends and family. Bye!